squared, cornbread are round. Okay? So to figure out the area of the circle, it's pi, which is represented by this little squiggly thing that looks like that. It's basically a T with two little lines coming down. It's a Greek letter, okay? Because the Greeks are the one that supposedly found out what this is, okay? If we want to know the area, that's times the radius, r squared, okay? If we will take a look at angle, let's see if that area of the circle, this is not the one I'm looking for. Let's see what we have in here. Yep. That's axis, trapezoid, half a circle, whole circle. Yeah, don't want that one. Don't want that one. Let's see, let me go into that. Oops. Back to find what I'm looking for. It's axis. Well, that's not exactly right. Okay, I will teach y'all the easier way than that. Those formulas are too complex for what I'm going to do today. Here we have a circle. And the circle has what in the middle of it? Radius point. Point. Go back to the initial definition. You have a point. Okay? The distance from the center of the circle to its outside edge is called what? Radius. And that's designated by this little thing that says R. Okay? The distance from one side of a circle to the other is called what? Diameter, which is represented by D. Okay? So if I tell you I've got half-inch diameter pipe or half-inch conduit, what's the diameter? Half-inch. If I got an 8-inch pipe bollard, how wide is the pipe bollard? If I got a 2-inch chrome section I'm putting in next to a case of the Publix rebar, what's the diameter? It's 2 inches, right? So certain shapes you'll run into in construction have fixed widths, some are nominal widths, okay? So I'll give you an example. This is what? It's tube, right? Tube steel, all right? It's a square, that's right. It is a square. It is a square. It's actually kind of a square, and then it goes out. It's kind of a column. There we go.
Yeah.
So, square sections here, if you buy a 2x2 or 2.5 or a 3x3 or a 3x8 tube steel column, if you measure that, that will measure exactly the size indicated on your plans. However, if that was a 3-inch or 4-inch pipe column, okay, it wouldn't necessarily measure because that's the inside dimension on steel, okay? Because you have different wall thicknesses for strength. So a 4-inch round tube steel, half-inch tube steel column will be larger around, okay, than one that's a 4-inch by quarter tube steel, okay? So the strength of your round sections won't always be exactly the same, okay? So that's just one of those things to confuse you on numbers of what things really mean, okay? Getting back to purchasing, you just have to know. Sometimes it's fun to sit there and say, they call that an 8-inch tube steel. I'm gonna measure and see, okay? It's not 8 inches. And you look at the wall thickness and you compare it, pick it up. So just some fun stuff to do when you're watching. But for our simple purposes here, I want you to pay attention to the radius, and I want you to pay attention to the diameter, okay? The radius and the diameter. Now we know pi is one of those numbers, which has come down to us from antiquity, right? Because we know the Greeks had it. They were bad. They were hanging around before the time of Christ, right? And let's see. So let's take a trip back right now to King Solomon's temple. Anybody familiar with King Solomon's temple? What that was? Okay. Basically, King David one of the kings of the Israelites, decided that he would build a temple in Jerusalem. It's where the Temple Mount is now, the West Wall, Wailing Wall. Y'all probably seen some of that in the news. But he was going to build a temple to his God, okay? And he was instructed, according to our ancient text, that he was not going to get to build that temple, but his son Solomon would build that temple. And so Solomon was given very specific instructions on the size to build this temple, okay? And when we get into our plan reading classes and things of that nature, we'll use that building as a model for us to take words and turn them into shapes, okay? But going back to pi, there is a link here. I know it's a stretch. Going back to pi, part of this temple is that they made a giant molten bowl to wash things in, okay? It's like a big cauldron, so to speak. And it was called the sea, okay? It's like a big bowl. And he said that the molten sea will be 10 cubits. Okay. Anybody know how long a cubit is? Okay, that's 18 inches, right? Write down 18 inches. All right, how many feet is 18 inches?
1.44.
Yep, take 18 divided by 12, what do you get? Yeah. Okay, so it was 10 cubits, which is 10 times 1.5 is how many feet? Be 15, right? 10 times 1.5 is 15. He said he made a sea of 10 cubits from brim to brim, edge to edge. It was 10 feet. So what is that? Brim to brim, it's the diameter, right? Okay. It was round in compass. So what does that mean? It was a perfect circle. Okay. And it had a line around the perimeter of 30 cubits.
Where did the times 10 come
10 feet, 10 cubits in diameter. Okay. So what we did is we converted cubits into feet. Okay. A cubit being 1.5 feet. It was 10 cubits. So we used our weights and measures table, right? And we took 10 cubits and turned that into feet. So 2, 4, 6, 8, 10, 12, 14, 16. So that thing was from here to here in diameter, okay? Just get a visual. It's nothing magic in it, it's just, it's a story. It's a story, okay, it's a story. Now, it said that in a line of 30 cubits did encompass it round about. So in this story, D is equal to what? 15 feet, right? Roundabout was 30 cubits. 30 cubits equals what? How many feet? 45. So, and this basically is called the circumference. Is 45. Okay? So to determine the circumference of a circle, we know that C is equal to 45. And we know that C is equal to 45. We know that the diameter is equal to 15. And we know from what the Greeks taught us that pi times d is equal to the circumference, right? That's just one of those formulas you need to memorize. Pi r squared and pi d, okay? Pi r squared, cornbread r, round. Do a diddle, or you can remember, okay? Pi r squared is the area of a circle. Pi d is the circumference, okay? And we know pi is equal to 3.14. Interestingly, if you divide 45 by 15, what do you get? Get 3. So going back to 1,000 years before the time of Christ, the Israelites had figured the first digit of pi. First digit of pi. They figured out what it took to go around. They knew that around the circle was approximately 3 times the diameter. Okay. Now the Greeks took it further because the Greeks understood decimals. Okay. The Israelites, at least what history teaches us, did not have a concept of decimals. They had cubits. Everything was in cubits. When we first started, we talked about the Egyptians used knot ropes, okay, to measure blocks of stone. Okay. So as time has gone along, through the use of arithmetic and mathematics, we become more accurate. Okay, we become more accurate. We can go to lots of digits. Okay. The point being, we go back almost 3,000 years, they're starting to figure out pi. What pi is. That's why it's important. Okay, it's one of those foundation building blocks, property of a circle that you just got to memorize. You'll say pi is 3.14. Okay, how many pies do we want for dinner? 3.14. Not 4. Yes, sir.
Where did 45 come from?
30 cubits times 1.5, 1.5 feet in a cubit. 30 times 1.5 is 45. Now, why did I throw out cubic, guys?
Unit of measure.
It's a unit of measure. Okay, I didn't give it to you to confuse you, okay, at all. But what we did is that we converted one unit of measure into another. Okay? Well, we took inches and we converted it into feet. We converted one unit of measure into another unit of measure. Why do we convert things into the same unit of measure? What's the overriding reason besides being accurate?
That's the system.
It's a system. You gotta know how to purchase stuff. Okay? You gotta know how to purchase it. When you buy things, you have to know how you're buying them. Okay? And everything you have on a construction site is bought by different units of measure. Okay? We know concrete's bought by the right. Okay. We know that metal studs are buying by the size and linear footage. Okay. 2x4s are bought by what?
Your piece.
Can be piece.
And linear footage.
Can be linear footage by size. We know we have a size. We have length. Okay. If you're buying it in bulk, what's the unit of measure? Board feet. Okay. There's another unit of measure. Okay. If you're buying reinforcing steel, you're buying it by size and length and weight. Of course, this is beyond what we're talking about with math. The reason we're going through this is to say, okay, learning how to convert this stuff will help you further in the next courses that are coming. That's why we get these building blocks in, okay? Remember when we started this class, we said that this is the foundation. What we're going through today is the foundation in which you will build your geometric structures of your career. This is a fundamental building block of your career to help you move forward, okay? Full of numbers. Okay, so let's do a little bit of circle work. Okay, if I have a circle which is 15 feet in diameter, that'll make the radius what? 7.5 or 7.5 feet. The area of a circle is equal to pi r squared. Okay? What is the square of 7.5? 56.25. Would everybody do that on their calculator? 7.5 times 7.5. Is that 56.25?
Yes, sir.
What's pi equal to? What's the area of that circle?
176.63 cubic.
Square.
Oh, yeah, square.
Square feet.
Square.
Okay, area. Now, if we wanted to do a cylinder,
Right. Just volume.
you'd add that third dimension. Third, length is 1, square is area, 3 is cube. Okay? So, why do you need to know the properties of a circle? Anybody here laid out curb and gutter? Okay? If you're ordering concrete for curb and gutter, you got a 30-foot radius, well, let's say you got a 7.5-foot radius. How big is that quarter of a circle? We know our diameter is what?
2.5.
If we take 1/4 of 45, 1/4 is 0.25 times 45 equals what? 11.25 feet. So we know that this distance here is 11.25 feet. Make sense? So we know that on a typical 24-inch curb and gutter section, okay, 6 inches deep, got a curved section on the half, you're running roughly 1.25, 1.33 cubic foot per running foot of concrete. It's a reverse, a curb and gutter's a reverse of a turn down, isn't it? Same shape, it's just up. Once you know the distance, you know the area at the end, you can calculate volume. Now, why is it important as a superintendent to calculate volume besides knowing what to order? How much to order, but also to be sure you're not getting short shipped. Okay? Anybody here ever been on a job where concrete vendor short ships a load? Okay. A lot of these guys will put together a 22 cubic foot yard instead of a 27 cubic foot yard. As superintendent, when you get 9 yards of concrete or 8 yards of concrete on a 4-inch slab, it should go a finite area. If it doesn't, there's problem quality control. One of your jobs as superintendent as you go through is to be sure that the company is getting what it's bought. Okay. We buy a yard of concrete. Do we want 28 cubic foot yards? No. Do we want 22 cubic foot yards? No. We want 27 cubic feet because that's what we bought. Okay. Now, I will guarantee you that when you are a newbie superintendent, and those of you who have been superintendents will know this too, you will be tested by your vendors to see if you are watching. And if they figure out you're not checking concrete yield, that concrete vendor is getting ready to short ship you, okay? Not all of them, but it kind of runs with the genre. So learning these numbers, okay, it's just not learning, it's dollars and cents too. Okay, it's dollars and cents too. Knowing how thick a slab is, you get a sub that's not fine graded to the proper thickness. Okay, you need to know whether your yield's right or wrong. You start pouring a 4.5-inch slab instead of a 4-inch slab, you got an automatic overrun, right? Okay. Now, did the estimators figure that overrun in? Not the ones I know. Okay. Most of the estimators will include the sawdust in the cutting list for the lumber. Okay, you might have one piece left over. You know, concrete yield, they may have 2 or 3% overage figure in that estimate, but no more than that. So, once again, getting back to circles, you use circles on radiuses, you use them on arcs and things of that nature, okay? So, let's do a couple other things, and then we'll go to question and answer. Let's just play a little bit here with circles. Okay, at least 2 digits. At least 2 digits. Your favorite number.
7.
That's not 2 digits.
No, I mean, you would have heard him, so do 77.
77. Okay, sounds like you're gambling. Okay. 22.
This is my favorite number. It's 23.
48.
Jimmy Johnson fan. 52,
61.
61,
33.
33,
88.
88, Dale Earnhardt fan,
11.
11,
12.
12, I heard a 12,
Miguel,
14.
14,
Brian,
24.
24. Is that
six-
everybody?
16.
16.
That's
Okay,
everybody.
everybody write those down on your paper down the column. Left-hand column, new page. Write all those numbers down. Everybody got them? All right. This is the radius of your circle in feet. Okay? How do we find the area of a circle?
Pi r squared.
Pi r squared, okay? So we know that for the first one, we will take 77, we'll square it, and we'll multiply it by 3.14. So take your calculators, and let's figure the area of each of these circles.